Broadcast is now starting. All attendees are in listen-only mode.
Well, hello. Welcome everybody to our pajama presentation webinar today for Friday, May 22nd. We're excited to be with you. We've got a few guests here with us that I wanted to recognize and introduce. We have with us Heather Christensen from Geneva Pipe and Precast. How are you, Heather?
Doing great, Jason. I'm glad to be here.
Good. Also from formerly from Oldcastle Infrastructure and now with Geneva Pipe and Precast, Mike Blackham, the transition between the two companies, Mr. Mike Blackham. How are you, Mike?
Thank you, Jason. Good afternoon.
And last, but he'll let you know he's certainly not least of all of us, Mr. Randy Wallen from Oldcastle Infrastructure. How are you, Randy?
So, well, I just got on, but did you say Mike was transitioning?
Yes, that is exactly what I said, Trandy. Anyway,
okay.
So there's a little throwback to about 6 or 7 weeks ago for you there, which was a throwback to January. So here we go. We're going to go ahead and get started today. We're going to be talking about post-installation inspection in pipes. As I've mentioned before, all of these webinars are available online. If you want to go to our YouTube channel, search Mountain States Concrete Pipe Association. I try to get those posted the night that we do those, so they should be available this evening. Great Friday night activity with the date night. You know, if you wanted to go on a date and rewatch this video. Don't spoil the ending, obviously, for your date if they haven't seen it. So just be respectful and no spoilers. But yeah, that will be available tonight. We're gonna have some poll questions throughout. We're gonna have some videos of things that I'm going to share with you. I'm going to try some new things today. I'm still kind of experimenting with this GoToWebinar, seeing how some things work. But when we do the poll questions, just wanted to remind everybody that if you're watching this in full screen mode, some computers won't allow you to vote. So if when we get the poll question, if you would like to vote, then you can drop your screen out of full screen mode, and then you can vote, and then you can go back to full screen. So as always, we will be watching to see who is the most attentive, who is paying attention, and that includes answering the poll questions and focusing and paying attention, and then we will be rewarding the person with the highest attentive score at the end of the presentation. So those are just a few housekeeping items. We'll go ahead and get started. For those of you that are new and haven't been to any of these presentations, I am Jason Allen, the Director of Mountain States Concrete Pipe Association. I graduated from the University of Utah with bachelor's and master's degrees in civil engineering. I've been in the civil engineering field for 18 years, done surveying, land development, worked in the public sector as the Morgan County engineer. I did consulting engineering, mostly drainage and roadway design for the DOTs and for municipalities. And now I do marketing engineering for, as I mentioned, the Mountain States Concrete Pipe Association. We are made up, and we want to recognize two producer companies and then two cement supplier companies. We've got Geneva Pipe and Precast, and we already introduced you to Heather and Mike from Geneva Pipe, and also Oldcastle Infrastructure, and I also already introduced you to Randy. We also want to recognize Ash Grove and Wholesome Cement Companies for all they do in our association. So this is, as I mentioned, a pajama presentation. This is our 9th and what I would consider our penultimate or our second to last pajama presentation. After next week, we're going to be scaling these back to maybe once a month. If we have a topic that we're really passionate about, we may do 2 a month as requested last week in our poll. But most people agreed that they want to keep these webinars going as an opportunity for continuing education and to build the technical skill. We're hoping that we can provide you with some type of break and provide some level of entertainment to you. And that's our goal. And then last but not least, it allows us, not just myself, but I think Randy and Heather to some extent, thrives on this as well, but we want to be the center of attention. That is really important for us. As always, I wear my pajamas, and today's pajamas, if you want to know what my pajamas are today, I have a great one here for you. This is because it's my absolute favorite animal, so my son MacGyver definitely wanted me to have this. He saw it and just had to get it for me. This is my elephant pajama. This is my elephant onesie. And if you're keeping score, Heather asked the question, how many onesies do you own? And I believe if you're a 39-year-old man like me, any answer that is not 0 is probably the incorrect answer. But I think if you're keeping score, this is what, five onesies now that I've worn. But anyway, that's a lot of fun. As we go through this, you may have questions. I would invite anybody to answer or ask any questions. There is a question thing there. And so, yeah, go ahead, and if you have any questions, feel free to put those in there in your question box. And let's go ahead and get started then. You can also comment and tell me, how much you love my onesies, which one's your favorite. We may have a vote at the end. Maybe next week we'll do a poll and see which pajama was your favorite for those that have attended more than not. But let's jump right into post-installation inspection. I've got a lot of information that we want to cover today that we want to get with you. So we're going to jump right into it. This is a little bit of a plug for next week's presentation as well. I've decided to set this up a little bit differently and show you a feature that you can do in PowerPoint that I'm actually going to be explaining next week in our presentation. Next week, I'm going to be talking about advanced PowerPoint techniques, and so that you can get the most out of your presentations. We got that request from a number of people that they wanted to know some of the tools and things that you can do in PowerPoint. And so today I'm setting this up and structuring it a little bit differently, and I'm going to show you how you can use the Zoom function. So I'm doing that today as kind of a plug so that you'll come back next week and learn how to do that. So with that in mind, we'll go ahead and get started in the presentation. So these are my 3 takeaways that we're going to be talking about today. We're going to do a brief recap of installation. This was, if you remember, we had a presentation about 4 or 5 weeks ago about installation of pipe. We talked mostly about concrete pipe, but we did highlight a few of the differences between rigid pipe and flexible pipe. So we're going to do a very brief high-level review of that. We're going to talk about cracks and deflection in flexible pipe. So cracking in rigid pipe and deflection in flexible. And then we're going to discuss what methods of post-installation inspection there are and what we should be looking for and watching for. And so I'm hoping that if this sparks any questions or makes you think about, I wonder if we're doing this in our projects and on our specs. I'm hoping that this will challenge you a little bit to see what areas maybe you can improve on your projects and in your specifications. So as I mentioned, we're going to use this Zoom function, so we're going to jump right in here to installation. So before we do this, well, we'll go ahead and do this here, this one right now. The bottom line: buried pipe must perform 2 critical functions. Anyone who's come to any of my presentations, I talk about this all the time. So you've probably seen this so many times. Every one of you is probably, scratching your head at home going, why is he saying this again? But it's very important that we remember it's a conduit, which means we're getting our storm water or our sewer water or our culinary water or our conduit for our electrical lines or whatever. We're getting something from point A to point B. That is the conduit part. But we have to be able to withstand a load above it. So our pipe system also has to be a structure. Okay, so why don't we jump in to do our first poll here? I've got 2 questions that I'm going to ask you. All right. And the first one is this. It's about concrete pipe, for reinforced concrete pipe. The structural pipe zone for reinforced concrete pipe is just the pipe, the bedding in the pipe, the bedding, the pipe, and compacted material of the spring line, bedding, pipe, and compacted material 1 foot above the pipe. Which one is considered the structural pipe zone? I should have clarified this. This is based on our installation spec that we gave a couple of weeks ago. Some specs may differ and may vary, but and so this is manufacturer's recommendation. What are they here? It looks like a number have voted here. All right, we'll give it just a few more seconds. So based on manufacturer's recommendation, the structural pipe zone for RCP is, I'm going to close it out here and share the results. Okay, so about half of you said bedding, the pipe, and the compacted material up the spring line. 40%, 41% bedding, pipe, and compacted material 1 foot above the pipe. A couple of you said pipe only and bedding and pipe. So typically for reinforced concrete pipe, as per manufacturer recommendation, the way we design these pipes, so the way the pipes are designed to be able to withstand the load, once you have compacted up to spring line, that pipe now meets its structural capacity. That is what we designed for. So if you chose C there, bedding pipe and compacted material to spring line of the pipe, which is that middle part of the pipe. If the pipe's flowing half full, it's that line right there at the middle there. That would be correct. That is the correct answer. Wonderful. So thank you very much for that. Let's ask another question here. This is typically the structural pipe zone for flexible pipe now. So what is the typical pipe zone for flexible pipe? Same answers here, pipe only, bedding and pipe, bedding pipe, a compacted material up to spring line, or bedding pipe, a compacted material 1 foot above spring line. Okay. And I guess a lot of times this depends on if you're referring to the specifications or if you're asking a contractor, because you're probably going to get a different answer there. Okay, I'm going to close it and share it here. 97% of you said chose the correct answer, bedding pipe and compacted material 1 foot above the pipe. So that's typical. And as I mentioned, some specifications may vary. I know, some specs will say to have concrete pipe, you would design or build it so that it goes at 1 foot above the pipe. That's, like I say, specifications may vary, but the way these pipes are designed is for the structural capacity. For reinforced concrete pipe, it's there at the middle of the pipe or the spring line. And then with flexible pipe, it's typically 1 foot above the pipe. Sometimes it could be more or less depending on what material you're using or how it goes, but that's pretty typical. Okay, so let's go back to this presentation now, and we'll look at our soil pipe system. This is, again, from our installation presentation that we gave last week. If you look on the left, you've got your flexible pipe with your pipe zone. So the pipe itself is flexible, so it's very important that when we load that, we have to have something stiff on the side or it's going to want to deflect outward, right? So it's going to want to squish a little bit and deflect outward. So if we put really strong compacted material on the side and get that good compaction and build it up over and bridge on top of the pipe, then we're going to be able to withstand those loads. So it's not going to deflect past what's acceptable. If you look on the right now, you've got your rigid pipe system where, as you can see, you've got that structural material up to spring line. You've got your pipe there and then just your trench on top of that pipe. So when we load this, the pipe itself is the stiff material. So it's okay if we have a little bit more flexible material on the sides there. Obviously, we want to meet all of the requirements of our trench backfill so that we don't have settlement in the road and issues with that. But as far as the structural capacity, that's what we're looking at there, because two things when we're dealing with structure, we want to make sure, and we're going to talk about it next, we're going to talk about cracks and deflection. And so one thing that we're really concerned about is that we're building these pipe systems, whether it's a rigid system or a flexible system, we're building them so that they can meet their structural capacity so that we're not having major issues in the future with either cracking or damage of our rigid pipes and major deflection or obstructions and issues with our flexible pipes. So keep those in mind. That's why I'm really trying to hammer this home with, it's important that we make sure we install them and design them to withstand these structural loads. Okay, this was my comparison that I gave, if you remember from a few weeks ago. You can always go back and watch it on YouTube, but this is just that high level comparison between rigid and flexible, just so that we're understanding and we're on the same page here. So one is a structure, rigid is a structure, flexible is a liner. The pipe zone, the rigid we mentioned is at the spring line. The flexible is typically 12 inches above the pipe. Lift thickness in our specifications, the national specifications, the manufacturer recommendations, it's not specified. Local jurisdictions may have their own specifications and recommendations, but this is just for the manufacturer's recommendations and the national specs. For flexible, it's 4 to 6 inches, uncompacted lifts, and then compacted. As far as a structure, we provide the structure in the plant. We're manufacturing that pipe and testing it in the plant. For flexible pipe, we're building that structure in the field. So it's very installation sensitive, which is why it's important that we're talking today about installation and how inspection to make sure that these things are built and installed correctly. All right, so the structure design, that is handled for rigid pipe, it's handled by the manufacturer, and for flexible pipe, it's handled by the project engineer. So there are some differences. Just because it's a storm drain pipe doesn't mean that the materials are interchangeable. There are some differences, so we have to make sure we're understanding those differences as we go. So Let's look here. We'll go back to our takeaways and our agenda here. So let's move now into cracks and deflection. Okay. So things we know. All right. 1, we know that concrete cracks. If you've ever poured a foundation of a home or sidewalk or anything, we know that under certain situations, concrete will crack. Whether it's, your freeze thaw or your, it's loaded too much, that, structural issues. We know that concrete cracks. All right. And we know that with flexible pipe, the tendency is that it's going to want to deflect, right? If we load it too much, it's going to deflect. Those are the things that we know. So before we move on to talk about what's acceptable, all right, let's do a poll. Let's see how much we know here. If you watched our very first webinar back in March, we talked about the fundamentals of RCP. I'm going to launch this one here, and it talks about what is an acceptable crack width per ASTM C76. Is it 0.001 inch, 0.01 inch, 0.1 inch, or 1 inch? What is an acceptable crack width? Okay, this is per ASTM. This means there's nothing that needs to be done. You don't have to do anything with this. If you've got a crack this size or smaller, then that's fine. There's nothing that needs to be done. Okay, there's no repairs necessary.
Hey, Jason.
Randy.
I had somebody text me a question. They asked if you had bear pajamas.
Bear pajamas, I mean, I do when I sleep.
Well, wait a second. No, he said a teddy. I think that's different. Anyway.
Oh, okay. I see. I thought he was asking if I sleep bare naked, and no, I have too many onesies. Okay, so I'm gonna close this and share it. It looks like 69% of you, nice. 100th of an inch, that is correct. Well done. 22% said 0.1 inch. Now, the 6% of you that said 1,000th of an inch, you would also be correct because that is less than 100th of an inch. So technically that is acceptable and you wouldn't have to do anything. But the number that we're looking for is that 100th inch. All right. And we'll talk about that in a moment. For that 10th of an inch and that 1 inch, those are some pretty significant cracks. However, it doesn't mean that with 1 inch, yeah, you're probably done. That one's probably a remove and replace. For a 10th of an inch, though, there might be some things we can do, and we'll talk a little bit about repairs in just a moment. All right, so why don't we do another one? And this is per local specifications, all right? So per APWA and UDOT specs, deflection in plastic pipe, in most plastic pipes that's acceptable, is blank percent. What is it? Which is this per APWA and UDOT specs? This is acceptable. And some of you out there might be trying to outthink yourself here and think yourself through, because there are some caveats to some of these, which we'll be discussing in a moment. But this is just kind of that general rule of thumb. What is acceptable in most plastic pipes here? Okay, looks like we've most have voted here. I'll close it and share. It looks pretty even, actually. 28% said 2.5%, 31% said 3%, 41% said 5%, nobody said 7.5%. The correct answer is 5% or less. So technically, you're all correct. If you put 2.5%, 3%, those are correct. Those are acceptable. But you are allowed to go up to 5% deflection in plastic pipes. If you had in APWA, for instance, in section 330800, this is the commissioning water lines section, great section in APWA. This one talks about deflection in metal and plastic pipe, and like ductile iron pipe, for instance, is considered a flexible pipe. The maximum deflection in ductile iron is 3%, but corrugated metal pipe, on the other hand, can deflect up to 7.5% per APWA spec. For UDOT spec, it's both 5%, and then anything between 5 and 7.5 is reviewed by an engineer. But we'll get to that in a minute here. I'm getting a little bit ahead of myself. I'm just too excited. So here we go. What is acceptable? We talked about that. Cracks per ASTM C76, 100th of an inch. Now, the definition of this per ASTM C76, so that you know, a 100th inch crack is one that is at least 12 inches long, right? So if it's less than 12 inches, if it's only 6 inches long, that wouldn't even be considered a 100th of an inch crack. This is one that is 12 inches long, and you're able to put a 100th of an inch leaf gauge inside the crack at least 1/4 of an inch. Okay, so if you can't even get a tenth or 100th of an inch leaf gauge in it, a 1/4 of an inch, then that's even less than 100th of an inch crack. So that's even smaller. So obviously it would be acceptable there. All right, these are both referenced in UDOT and APWA specs, the ASTM C76. So this is acceptable per, if you're using APWA or UDOT specifications, you can allow 100th of an inch crack. Those are acceptable cracks. And it is often referred to as a hairline crack. For both of these specs, APWA, UDOT, and most local specs, if it's greater than 100th of an inch, then the recommendation is to evaluate that and look at if there's any repair necessary or if it's going to be okay. And this is the hard part about cracks and reviewing videos and things, right? Every situation's different. Every crack is caused by something slightly different. And so when we review pipe videos, Randy, Heather, Mike, myself, when we're reviewing these, we're asking a lot of questions. We're trying to get all the information. It's almost like we're doing an investigation. It's what caused this to crack? Was it construction loading and now it's seen its full load? Is it continuing to crack because it wasn't installed correctly to handle the traffic loads above it? Or like, what's causing this problem? What are the issues? And so you've got to ask a lot of really pointed questions to try to get to the bottom of what caused this crack in the first place, because two cracks that look the same may not be the same just because of what's causing them. If one is caused by significant loads early on and it hasn't seen any loading, that's different than one that is continuing to be subjected to heavy loads and it's continuing to increase in cracks. So you've got to ask these questions and kind of try to find things out. This is a picture that Randy showed this to me one time, and I love this picture because it shows some of you may be looking and going, wait, is there a crack there? So don't look at the chip on the side of the picture there. This is a pipe, and I'll explain why I don't want you to focus on that. I want you to focus on the crack, okay? And I'm going to get my cursor here, and if you can't see it, this right here is where that crack is. This is a crack in a pipe where the contractor was required by the owner to remove and replace this pipe because of this crack. Let me show you again. Because of this crack right here. Okay. Now Randy put his business card in there. He usually has his hand in the pictures, but I said that's not a good representation because it's your hand's so big, Randy. You just have such large hands, is why it's not a fair representation. So I said, show you. He put a business card in here, but you could see there is no way you're getting 100th of an inch. That you're getting 100th of an inch leaf gauge inside this crack. There's just absolutely no way that's going to happen, right? So you really need to, look at that and go, that's not even considered a 100th of an inch crack. That's even. Why would we need to replace that? Well, there's a lot of reasons, that they may have asked for that. One might have been that it was wet in the pipe when they did the video, and so it looked a lot bigger than it was. That's a concern when you're watching these videos and doing post-installation inspection. You got to keep an eye out for that. Some organizations just say, we don't want any cracks in our pipe. And I have to try to explain and educate the difference between crack-free pipe and pipe that meets the specifications. These cracks are not going to impact the long-term life of this pipe to where you're going to have to be replacing it. This little hairline crack, these happen. These are normal and they're accepted, which is why in the specifications, that national spec ASTM C76, it says that 100th of an inch crack or less is not going to be an issue. It's not going to jeopardize the long-term use of that pipe. So let's move on now. So the question is, well, how big is 100th of an inch? How big is that? I know you're all scratching your head wondering, how big is 0.01 inches? So I'm going to show you this here. Think of a dime for a second, all right? If you've got a dime, a dime is the thickness of 0.05 inches. So if you were to take that dime and cut it into 5 equal sections, that's what 100th of an inch is, okay? So that's pretty interesting to think, right? So if you think about it, you stack 2 dimes up, you get about the width of a nickel. That would be 1/10 of an inch. So that's how big that is. So it's relatively small, relatively minor. But that said, if we have 0.05 inch or 1/10 of an inch cracks. I'm not saying that we can't do things to remedy those situations, and we'll get into that in a moment. So now we'll move on. What about deflection? We had a question about deflection. Per APWA, for your thermoplastics, like your HDPE and your polypropylene pipe, that's a 5% maximum deflection for that, okay? And for CMP, I mentioned before, 7.5% maximum deflection. Those are typically what we're seeing most in drainage applications. Your ductile iron with water, typically you'll see that with water. PVC with like sewer, those ones are also in that specification as well. I mentioned earlier that ductile iron pipe is 3%, and PVC polyvinyl chloride is also 7.5% there. So those are what's acceptable with those pipes. Per UDOT, anything less than 5% is acceptable, so that you could just accept that. Anything between 5% and 7.5%. Now, mind you, this is for all drainage materials, so this is your plastics or your corrugated metal. Anything between 5 and 7.5%, that is an evaluate, and anything above 7.5% is a reject, remove and replace. And that's with your APWA. Anything for your plastic above 5% is remove and replace. Above 7.5% for corrugated metal, remove and replace. So keep that in mind. I asked the question one time, well, why is that? What's the issue with that? And one of my mentors and a great engineering mind that explained this to me, Mr. Jeff Enyart, who passed away last year, sadly. Jeff explained this to me really well, where he talked about how strong a circle is because it's in ring compression. So when you're loading a pipe and it's round, right, it's distributing those loads around the ring, and so it's in what's called ring compression. So it helps shoulder some of those burdens and accept that loading throughout the pipe. But once you start deflecting past a certain point, you're now looking at more of an arching situation, right? So it's more of an arch. It doesn't act as a ring anymore. It acts more as an arch. So you start losing the value and the benefit of that ring. And so it increases your likelihood and possibility that you would have a failure from and have that pipe collapse or buckle because it's getting out of ring compression. And so once you start getting up into the 10-12% deflection area, you're starting to get into that serious arching situation where you're losing the structural value that you have in that round ring compression pipe. So keep that in mind. That's why it's very important that we're really building strong side walls on these flexible pipes so that they're not deflecting beyond that 5% and in some cases 7.5%. Okay, so keep that in mind there. All right. So I know what you're thinking. You're a little saying, whoa, go back to cracks here. Why would any cracks be acceptable, right? We've had this question, right? It's a fair question, right? And city says, well, we paid for this pipe. We paid for perfect pipe. And then again, as I mentioned before, we have to have that conversation. Well, what is perfect? Is a perfect pipe one that meets the specifications, or is a perfect pipe one that has 0 cracks in it? That's what we have to define because there is a difference. Right. And I think we need to kind of step back and look a little bit about what the effects of cracks can have on our pipe system. Right. We need to look at this from 2 standpoints of what this pipe has to do. We talked about it before, conduit and structure. There's the functional aspect of a crack or a functional aspect of a pipe and the structural aspect of the pipe. So when we're looking at this, we have to ask ourselves, will this crack have an effect on the function? Meaning, will it affect the way the water, if it's a storm drain pipe, the way that storm water gets from point A to point B? If it's a really thick, significant crack, are we going to have infiltration or exfiltration in that pipe? Are we going to lose that water as we go through? Are we going to leach into the surrounding area there? What, is it going to be functional? Are we going to be able to get from point A to point B, right? And then the next one is structural. Is that pipe going to be able to continue to withstand that load? So that's what we're looking at when we're looking at these pipes, right? Is it going to be functional or is it going to be structural? If it has an effect on it structurally, then obviously we have a problem. We need to look at what we can do to strengthen that up, right? And we'll talk a little bit about some repairs that might be necessary in those cases. But where it's functional, and we're just worried about if there's a small crack, and we're worried about leaking water or infiltrating water, then that's a little bit different. And that's where we get into the theory and the idea of autogenous healing. Now, I know I talked about this a couple of weeks ago in our presentation that was about demonstrations. And so I wanted to go into more detail because I really think this is a fascinating idea and a fascinating concept. And so I want to go into this a little bit more from a science standpoint, and we're going to get a little deep here and a little scientific. So autogenous healing is the ability of concrete to heal itself. Now, for those of you that know Randy, I know that Randy likes to joke around a little bit every now and then, and there have been things that he has taught me and told me that when I look at him, I think, really? Is that true? Right? So as he's teaching me about autogenous healing, I'm thinking to myself, okay, it's the ability to heal itself, and it's when there's moisture present, it can seal the cracks. And again, this is what my face looked like. Now, wait a second. You know, I get that suspicious look, like, is Randy just pulling my chain here? Or is this really a thing? Is this really a thing? Well, it turns out it's really a thing. There is some science behind it, so we're going to talk about that. So when we have concrete, if you remember, concrete is like the cake, and there's all these different ingredients, right? You've got your water, you've got your aggregate, you've got your admixtures, and one of the most important parts of that cake that is concrete is your cement. Right? So inside this cement, you have some free calcium oxide that's just inherent inside the cement itself. All right? And so there's also calcium hydroxide. So this calcium oxide and this calcium hydroxide is liberated when tricalcium silicate inside the cement is hydrated by water. So as you mix that concrete and you add the water to the cement, you're hydrating this tricalcium silicate, and it releases this calcium hydroxide and the free calcium oxides within the cement. Now, in the soil, the air, and the water around the pipe, you have carbon dioxide, okay? So this carbon dioxide that's in the water, that's in the soil around it, that's in the air, what this does is it actually carbonates this calcium oxide and this calcium hydroxide. So it carbonates it, and when you carbonate calcium oxide and calcium hydroxide, something incredible happens. Okay, it goes through this chemical change in this chemical formula, and it creates calcium carbonate crystals, right, or limestone. If you've ever been to like a cave and seen stalagmites and stalactites and things like that, I took my family a few years ago to Wind Cave down in South Dakota, and they have these beautiful stalagmite and stalactites. That's similar to this. They're creating that calcium carbonate in that, and it creates this limestone, and it starts filling in the holes, and it seals these cracks. And what it actually does, it's very fascinating. It seals these cracks, and it protects the steel from corrosion. So people say, well, I'm concerned about this crack because if water gets in there and it corrodes the steel, then it's going to rust out. It's going to pop out the pipe there, and it's gonna cause major issues with rust and corrosion. And this autogenous healing actually prevents that from happening because it seals that crack, and it doesn't allow the water to get in there to touch the steel. So it's really fascinating. Okay, so for all my chemistry nerds out there, here is the reaction formula. So you've got your calcium hydroxide on one side, and we add to that the carbon dioxide from the water and the air and the soil, and we get this calcium carbonate or limestone and water. That's what we're left with in that chemical reaction, calcium carbonate and water. So that's why we need that water present there, so that it will take the carbon dioxide in that water and accelerate the process. The water also helps the calcium carbonate crystals to get in and penetrate that crack and start building and grow up and start growing and filling in that area there. So someone said to me one time, okay, well, what if there's no water in your pipe? And I said, is this a storm drain pipe? And they said, yeah. And I said, and you don't have any water in your pipe? And they said, yeah. And I said, why do you have a storm drain pipe with no water in your pipe? And they scratched their head and went, oh, that's a good point. Okay. I mean, if we have a storm drain pipe, we're hoping that we have water in it, or else why put in storm drain pipes, right? So when we're dealing with this in like sewers and storm drain applications, we know we're going to have water in the pipe. So this is something that we can count on happening for some of these smaller smaller cracks. Okay, so the question also, this is what it looks like here. If you see, this is an example of it in the bottom of a pipe there. You can see that white effervescent material there. That's that calcium carbonate. That's those crystals that have sealed that crack and filled in that area to protect the steel and to reconnect the concrete and seal itself back up. All right, so I know what you're thinking. All right, you're still a little skeptical. I get it. I can feel it. I sense it. All right, I understand. I know this is kind of an interesting, kind of a new thing, and until you see it, I don't blame you. I was skeptical myself. All right, so how long does this take? Okay, fair question. Fair question. All right. Typically, it can happen as early as days or a week, right? It depends on how much water you have. It depends on how big the crack is. That's the other issue, right? When you think about it, if you've got this small crack, right, and it's, say, 1/100th of an inch crack, and it takes some time to fill in and create those calcium carbonate crystals and fill in that crack. If we're looking at a larger crack, say a 5/100th of an inch crack, that's about the threshold on where this takes hold. All right, anything over 5/100th of an inch is going to be, it's going to have some issues, right? Because it's almost too thick and you've got almost too much water coming in and pushing in against it and what. So 5/100th of an inch is about the threshold of what we've noticed that this will actually work. And so your larger cracks, your 10th of an inch cracks or greater, it's really, really questionable on whether this will take hold and work. But it all depends on how long it takes. It depends on how long how big the cracks are is one thing, okay? But I did mention this demonstration in a couple of weeks ago. But this is an experiment that we did because we wanted to show some of the cities that were coming to our plant tours what this process was all about and how it worked. So we took a 24-inch pipe. It was a class 3. We cracked it. We actually took it to ultimate. So we took it beyond that 100th of an inch crack. I would say that these cracks that we were dealing with were about 5/100ths of an inch. Okay, they were, and they might have even been a little bit bigger in some spots, but 5/100ths of an inch is about what we took this to. Okay, we filled it with water and left it for about 3 weeks is all. Okay, and we then compared 2 pipes, the same pipe, we just cut it in half and plugged to the bottom and filled them both up with water. Now the one on this picture that you see that's closest to the screen, the taller one, you can already see the white forming there on the outside of this pipe, right? That was from 3 weeks ago. That's all it took, was 3 weeks for that to start forming and filling and sealing itself up. Now, you can see that there's still a little bit getting through that pipe, so it's still leaching. After 3 weeks, it's still going a little bit through there. But keep in mind, this is a pretty big, significant crack, all right? And as it goes in and seals, this is just after 3 weeks of being filled with water, okay? We also filled the shorter one over there. We filled that with water and compared how fast the water was coming out of that one. If you're wondering, after 3 weeks, same pipe, same crack, just cut in half. After 3 weeks, we compared the water flowing out of it. The one that was closest to us was flowing out at a rate of about 1 inch, 1 inch of water per 2 hours. We did a 2-hour plant tour and it had gone down about 1 inch. So we still lost about 1 inch of water in 2 hours after 3 weeks. By the time we let this thing sit for another couple of months, it was completely sealed up and didn't leak any water. The one furthest from us that we had just filled up that morning, that was just brand new, it was leaking at a rate of about 1 inch per minute, roughly, 2 inches per minute. It was coming out pretty quick. So it's a pretty significant difference that one would go 1 inch per minute and the other one was going 100 inches per hour. So it was real. We had to keep that hose in there to even keep it up. We had to keep it turned on so that it would balance it out. But anyways, that's just an experiment that we did, that we saw, and it was a really cool experiment. And like I say, if I hadn't seen it myself, I would have questioned it. So then the next question, I know you're still suspicious about this. I know it's an interesting, weird concept, right? Wouldn't that crack affect your pipe strength? Well, that is a fantastic question, because I've asked that same question. Okay, we've cracked the pipe now and it's healed itself, but we still have a crack, right? We want this pipe to be as strong as it is when we test it in the plant. We want to make sure that it can still have those loads on it, right? And maintain those loads. So now we take that pipe out into the field, contractor installs it, isn't careful with it, cracks it. Well, now that's going to affect the long-term strength of my pipe because it didn't have a crack when you delivered it. Now it does. Hey, that's a fair question. That is an absolutely fair question, right? I've asked the same question myself. So this is one that we sought out to answer. We at Mountain States a couple of years ago decided, you know what? Let's do an experiment. We've talked about this a lot, but I don't know if anybody's ever done this. I want to see what happens. So I have a video, and this is where, as I mentioned, I'm going to try something new. When I downloaded this video from YouTube this morning, there was no audio. I asked the original people to send me the video, and when I tried to convert it to an MP4, it did not work. So I'm going to try two different things here. One is I have a video that is a YouTube link. I've never done this where I haven't uploaded it. I've just linked it to YouTube, but apparently that's an option here, and we're going to try it out. We're going to see how it works. If that doesn't work, I have the video with no sound, and I can narrate it. But I'm going to try this, and we're going to see how this works. So I'm gonna play this video here.
One question the American Concrete Pipe Association often hears is, why is minor cracking in concrete pipes okay? The answer is found in the principle of autogenous healing. Autogenous healing is concrete's ability to heal itself in the presence of moisture. The visual indication of autogenous healing is a whitish substance known as calcium carbonate. The American Concrete Pipe Association demonstrates the principle of autogenous healing in a test.
Hey, Jason.
Yeah.
There's some echoing going on in the video.
Pipe had gained an additional 20.
Okay. All right. Heather said there was some echoing. I apologize if there was echoing in it, but it sounded like it was working. I tried to I unmuted myself in case I needed to talk over it, and then that might have been what the echoing was that you were hearing. But just to summarize, that was an experiment that we actually did in the Ogden plant there at Oldcastle, and we tested it, we cracked it, we took it to Ultimate, and then we healed it for just a couple of months. And then we recracked it, and we saw a 23% increase in strength. Interestingly enough, the other question we get is, so did it crack in the same location? No, it didn't actually. We tried to align it as close as possible to where that crack was when it originally cracked. So we wanted to orient it. We marked it to see where it was, and then it took a lot of finessing to get it in there at that same location, the same orientation. And when we cracked it again, it didn't crack in the same location. So that was really kind of an interesting thing there. That it created a new crack when we took it to Ultimate, and it withheld 23% more strength or more loading capacity there. So that's kind of a cool little thing there. That when a pipe cracks and then heals itself, as the concrete continues to cure, and because the calcium carbonate is strong enough to bind that crack, you'll see an increase in strength. So that's why over time, as concrete cures, continues to cure and continues to gain in strength, if we have these hairline cracks, that's why we're not so concerned with them, as long as it doesn't affect it structurally. So something to keep in mind there. Okay, so let's look back here at what are our options here. What are some repair options if we see these cracks? All right, for 1/100 of an inch or smaller, no repairs necessary, as we mentioned. That's per FHWA's handbook. And per the ASTM C76 specification, nothing required. Now, if you have some larger cracks, let's say you have a crack that goes all the way through the pipe, all right, and you're worried that it's going to be leaking, and and this is a situation where maybe autogenous healing isn't going to work. I've seen somewhere you've got a weep hole and water spraying through, right? You got a gusher. Okay, because there's maybe some high groundwater outside and it's pushing against it. That gusher's never going to get through. If you've got a big crack and it's gushing through, it's never going to slow down, right? For the chance for those calcium carbonate crystals to form to seal that hole. And so it was interesting. I saw one situation where we reviewed a pipe and there was a big gusher, and then the next year we went through it again and it was gone. There was nothing. There was just a little bit of a weep stain there. where it looked like it was just, and I thought, well, that's interesting. It was gushing before. Well, it turns out that they filmed the first video during really high groundwater, and then over the year, as the groundwater receded, it had just enough water and moisture in that crack, in that hole, to seal it, to do the autogenous healing. And then when we came back and reviewed it at high groundwater the next year, it wasn't gushing anymore. So if you've got a constant gushing, you're probably not going to get that autogenous healing. But if that groundwater recedes to a point where it's just a slow trickle of water through there, you might be able to see that autogenously heal throughout that year period. So that was just kind of an interesting anecdote that I had there. But if you have one that goes all the way through the crack and you're concerned about it, injection grout is a viable option. You can go in and injection grout it with a non-shrink grout that will seal it off so that it's not leaking. A grout sleeve is an option. A grout sleeve is where you go in and you expand this sleeve that actually you leave in the pipe. This could have some impacts on hydraulics, this is why when we talk to contractors and we start going through these repair options and we say, look, some of these are pretty costly. It's much cheaper than remove and replace, obviously, but these are costly. This is why you need to be taking great care to ensure that you're installing it correctly. You're not putting heavy construction loads on it after it's in the ground, things like that. And another one would be a liner, going in and lining the pipe, whether with a structural liner or just a liner, so that this is more of a functional thing. So these are more if you've got functional issues with the pipe, where it's maybe leaking or it's taking in water that we don't want, the groundwater coming in. So for these larger cracks, these options are more if it's that functional situation, right? But if it's a structural thing, then we would look at maybe either a structural liner or pouring a concrete collar around it. The last resort is always a remove and replace. But the impacts on that's why we stress so much upon inspectors and contractors. Let's make sure these are getting in the ground correctly up front. It's so much cheaper and easier to do it that way. Okay. So, but those are some options. Just keep in mind that you can repair if there's any issues there. All right. So, our last little part here, our last of our 3 things we were going to discuss today. Let's talk about inspection. Okay. Broad question here. Why? Why do we need post-installation inspection? Like, what's the point? Like, is it really that important? All right. We're gonna do a poll here. All right. I just want to ask, what percentage of your projects are currently enforcing? Not what percent of your projects have it in the specs, but which percentage of your projects are currently enforcing post-installation inspection? So if it's video for concrete pipe, what percentage are you actually videoing and reviewing those videos? Or if you're requiring a mandrel test, how many of those are you actually requiring a mandrel test per the specification? All right. And so, are your projects, is your city or your municipality or when you're the RE on a project for either UDOT or for a city project, like how many of those projects are you really doing good post-installation inspection and reviewing it? Okay. And that doesn't necessarily mean that you're only checking, 25% of the pipes, but are you, how many of your projects are enforcing? Looks like we've got quite a few voted here. I'm going to close it and share. About a third of you say 100% of my projects. That's great. That's wonderful. I think that's a very good thing. All right. A couple of you, one of you maybe said 75%, about 3/4 of your projects you're enforcing. That's good. 18% said 50%. So half of your projects are being enforced. It looks like a pretty good percentage are either 0% or a quarter of it. That's interesting. That's good to know. That's very good to know that that some of our projects are not doing post-installation inspection. I'm going to talk for just a minute on the benefits and why post-installation inspection is important. Okay, so the benefits of that: number one, it ensures that the pipe that's in the ground meets your standards. Right, it ensures that it's going to meet that, and it's just a great way to protect your investment. It's a relatively cheap and easy way to protect your investment and to provide an accountability check for installation. Right, if a contractor knows that you're going to be requiring post-installation inspection at the end, whether that's a video for concrete pipe or mandrel and video for plastic pipe, or even just video for plastic pipe. If they know they're going to have to meet those standards, you're going to see something a little bit different, I think, when you start getting in there, right? You're going to see that that something it's going to be a lot different. Okay, so they're going to install it a little bit differently. I'm not saying that they're all looking for really easy ways out, but you never know. I just want them to be accountable. That's what we want. Now, I say this with as much conviction as Alex Jones ranting about some crazy conspiracy. All right, I will shout this from the rooftop and say it loud enough for the people in the back. Post-installation inspection is not meant to replace inspection during installation. Inspection during installation is critical and very important. Now, I understand that a lot of cities, municipalities, we don't have the personnel and the manpower to be out there inspecting every single lift of every single pipe installed, of every single time we try to, do something. We don't have time for that, right? And we don't have the budget for that sometimes. I understand that. But we still need to be doing some basic checks during installation as much as we can. But post-installation inspection is it's a great way to keep them accountable during installation, or contractors, I mean. It's a great way for us to go in and say, okay, what happened? What did happen? Was this installed correctly? If it was, it should meet all of these standards. It should be able to pass the deflection test. It shouldn't have significant damage or cracking in the pipe, right? Those are things that you want to be looking for. And so don't just say, well, we're going to require that, so we don't need to do any inspection on the project. I would really be hesitant on that. I think they are great tools used together. And I think they should be used together in harmony to just double check where we weren't able to see every single lift going in, right? So keep that in mind. Some of the methods, okay, this is what's recommended in most of the specs, and what we recommend and what we want to see done on all of our pipes. We want things installed correctly. We want our pipe just installed incorrectly or installed correctly, just as much as you do for your end product. Our best marketing tool in the concrete pipe industry is a properly installed concrete pipe that lasts 100 years. I've said it before and I'll say it again. We're not Apple. We don't send you an update that will crash your phone every 2 years, so you have to go buy a new one for $1,000, right? If you put a concrete pipe in the ground, we want that thing to last not 100 years. We want it to last 150 years. So we are heavily invested in making sure the contractors install our pipes correctly. All right, we just if a pipe goes in the ground that's a concrete pipe, we don't want you to have to worry about it. We don't want your grandkids to have to worry about it, or your great grandkids to have to worry about it. That's our model. So that's why we recommend that you do some post-installation inspection and make sure if there are issues, we're catching them early enough to get them fixed so it doesn't affect the long-term life of your pipe. So for concrete pipe, the recommendation is CCTV and video reviews to check for things. And then with flexible pipe, the recommendation is both CCTV and deflection tests. And I'll tell you why in a minute. Some people say, well, we do mandrel testing. Why do we need to do CCTV? Or we do CCTV tests. We can tell how much deflection there is in a video. You got better eyes than me then. But here's the recommendations for CCTV. Some of these I pulled right out of the APWA spec. Some of them I pulled out of UDOT, but these are the recommendations of what you should be looking for when you're requiring CCTV and you're accepting the reports from the pipe video, the video review company, right? You should always make sure that they are NASCO PACP certified at the minimum, right? I am actually NASCO PACP certified. I know Randy is PACP certified. I went and took the 3-day training in Vegas a couple of years ago, and it was I guess it was last year. But yeah, it's good to know. It was good for me to see what their requirements are and what they're doing. Okay, the goal is to be slow enough that you could see issues. We've gotten reports from people that say, oh yeah, they sent this report in and it was so fast, they were just blowing through there. We couldn't even see anything. They didn't stop at the joints. They didn't stop at the cracks. They were just going fast, right? NASCO's recommendation is 30 feet per minute minimum. Okay, so that's how fast that should be going. So, if you have 300 feet of pipe, right, it should be taking you about 10 minutes to do that, to get through that pipe. Okay, stop and document the cracks and damage. Like I said before, people say, oh yeah, they saw a crack and they just kept going. They just maybe made a little note. No, stop and look at it. You should be doing full circumference at the joints. That's important to see that the joints are functioning properly in both concrete and flexible pipe, right? We want to make sure those joints aren't letting material in that could undermine our structure that we spent so much time and effort building, right? APWA says zoom where necessary. Now, I agree that if you need to get in there and get a better look, you can zoom. However, what these companies do is they see a crack, they zoom way in, and then they take a snapshot and they put it in the report. So if you're reviewing the report, you're looking at a report that shows this enormous crack. And you're like, oh my gosh, that thing's like the friggin' Grand Canyon. What are they doing in there? Damaging our pipe. Well, when you go and watch the video, it's a hairline crack. And because it's a wide angle lens and because of where it's oriented on the pipe and because they zoom way in, all of a sudden, this hairline crack in a 15-inch pipe looks like it's 2 inches wide. And so we've seen things, and when I mentioned earlier where a owner required a contractor to remove and replace that hairline crack pipe, that's those situations. It was wet, so the crack looked bigger. They zoomed way in, so it looked bigger. You know, there's a lot of things that are in play here that you got to be smart about. Okay, so what to look for when we're in RCP? We're looking for cracks. We're looking for joint gaps. We're looking for any damage. Right? We're looking for obstructions and sags. Okay, those are things we want to see in our line. That's what we're going to be able to tell in our thing. This is I've just got some pictures that I pulled off of videos because I can't show too many videos on this program, and sometimes they're a little bit harder to see than not. But this is a joint gap that had an exposed gasket. This could be an issue, right? This may not be able to seal correctly and keep the water out or water in. And so this is one where a recommendation would be like an injection grout to go in and seal that. All right, this one is one where this is at about this crack right here starts at the top there. This one is at about 7 o'clock or 8 o'clock, and then when you go to this other side, this one's about 4 or 5 o'clock. So this is one where it's just down at the bottom of the pipe in the bell, and so this is one where they weren't careful as they were putting it in, and they chipped the bell out, and this is one where you could go in and do an injection grout and seal it and make sure that it's protected there. But that's more of a functional thing. These two were functional, right? Those were functional issues. This is one where you're actually seeing the exposed gasket and the steel. So now we're starting to get in. We're starting to get in there with a structural concern there because the steel is exposed. So this is one where you'd have to go in and do like a structural grout sleeve or something to keep that steel in there and make sure that it's not exposed. And so, yeah, this one's a little bit beyond functional. This is more of a structural situation, okay? And this is one that is a circumferential crack at the top of the pipe here. And I show this one because this is that one where they zoomed way in. So when you look at that, it looks huge. But when you zoom out and you take it in context, this is a 15-inch pipe, that crack is probably about 1/100 of an inch, maybe two or even 3/100 of an inch. But that's one that would probably autogenously heal itself. Now, if we're real concerned, we can always injection grout that, but something to keep in mind. So things to remember: repairs are possible. It might be costly for the contractor, but still possible. And we in Mountain States are a very good resource for these, right? We want a good installation, like I mentioned. I'm going to take 2 minutes and just blow through here what we're looking for with flexible pipe, okay? We're looking for cracks, okay? If there's any cracks in flexible pipe, that's a big problem. Cracking in concrete pipe is good. Cracking in plastic or metal pipe is really bad, right? We're looking for joint gaps that could undermine the structure, right? We're looking for any damage similar to concrete pipe, right? We're looking for obstructions. If something's blocking the pipe or something, there's a protuberance in there. We're looking for sags. And also we're looking for non-elliptical deflection. It's not enough for just deflection, right? That 5%, we want to make sure it's deflecting elliptically. Non-elliptical deflection looks like this, where you see on that side there, that top left side, it's deflected non-elliptically. It's rounded on the bottom and the right side, but on the left, it's a non-elliptical deflection. These are some things that you might see if you're running a mandrel through, or you might feel, but if you're running a video, it needs to be repaired and replaced, right? This is an example of a mandrel, 9 fins as required by UDOT and other agencies, where you have those 9 fins and you got to pull it through by hand. You don't want to tie one of those up to your truck, your winch on your truck, and start pulling it through. It'll turn your pipe into grated cheese there. So be careful with that. You want to pull it through with your hand. Once it gets stuck, you document how far it is. You go in, remove and replace that section, and then do it again. There are some states that are doing laser videos that you could do the CCTV and distortion together. So instead of doing one test for CCTV that would show you your sags, your issues at joints, if there's any cracks, any of that with flexible, and then doing a mandrel test as well, you can go in and look, and this shows you true round, which is the green circle, and then red. Now, we don't have this typically available here in our Utah and Idaho markets, but we do. We have seen this in other markets where they've got that. It's very costly here because we don't really have anybody that requires it or does it, and so it's a little bit harder to get this done. It increases the cost of installation significantly because it's, instead of $1 a foot for the post-installation inspection, it ends up being 5 or 6 times that much. So hopefully if this technology becomes cheaper, it would be a great option because you can do the video and the laser at once. I do have a little video here that I can show you on what this looks like, and I'll kind of talk you through it here. So we'll see if this works, and then we'll just go ahead and this will kind of be the last thing that I talk about here before we end. All right, so they're going through. You can see the video as you watch here. You can see the, this pipe. You can kind of tell that it's pretty round. It might go, you see some weird little things here and there come in, and but for the most part, it looks pretty good. You saw a little obstruction at the top there, a little protuberance sticking in there, and as you're going through, everything's looking good, looking fine, and then we see that. So that is a problem. So let me show my screen again here. So this is what they saw. This was just a giant rock that they had put on top of the pipe, had compacted down, and it smashed in through the pipe. So that's a concern there. So our takeaways today. This is what we talked about. We had a good review of installation. We talked about cracks and deflection in pipes, and we also gave some recommendations for inspection and post-installation inspection. So here's my contact information. I'm going to put this up here. So let's see if anybody has any questions. I'm going to open up the question pane here. So far, I have no questions asked, but if you have any questions, feel free to share them. I'm trying to, whoops. Sorry, I went back too far there. Let's go back here. Sorry. So yeah, like I said before, make sure you're joining us next week. We've got some, we're going to go over some good PowerPoint stuff next week, some advanced PowerPoint tips, show you how you can make your own sections like I did today with the zoom function, and it adds a little bit of fun functionality there, but it looks like no questions today. I did get a text from someone about a central sewer pipe that was installed. They said they have a 60-inch pipe in Ogden that was installed in 1910. Perfect pipe. Pipe looks great, but their joints are leaking. So yeah, back in 1910, we definitely didn't have the joint capabilities that we have today. The pipe is great, but yeah, we've got some issues with joints that we can go in, and I'll have to reach out to you there, and we can go in and get that. So question is this presentation available for sharing with our inspectors? The recorded version, so we can get the Jason Allen version. Michael, I don't know why you would want anything other than the Jason Allen version, but absolutely. If anybody, and listen, I'm here, my main goal is to make sure that you as engineers, that whether you're designers, inspectors, or even installers, my goal and what my job revolves around is that you have the tools necessary to do your job successfully. Right. And so if ever, don't ever feel bashful about asking for one of my presentations. If you like a couple of slides in there and you want to incorporate them into a training that you want to give your folks in your office, please ask. I am more than happy to share every presentation I have with you. Michael, to answer your question, the recorded version, absolutely. It will be available. I will send out the link when I send out the PDH certificate this afternoon. It might even be later this evening, but when I send out the PDH certificate, I will send the link to our YouTube channel so that you can watch any of these presentations. They're on YouTube. I do have, if you don't have a capability, for instance, to watch it on YouTube, I have them saved as MP4s. I can Dropbox those to you as well if that works better for you. But yeah, absolutely. Any tool that I have, consider it yours. I want to make sure that you're you have what you need to do your job successfully. So great questions, Michael. But yeah, those will definitely be available. Any others about this presentation or any others? Yeah, well, it looks like there's...
I thought you got really excited during the chemistry portion of this, so they may want to fast forward through that a little bit.
I hated chemistry in my undergrad. It was interesting. I actually was thinking of going pre-med, and then I woke up one day and realized I'm way too smart to be a doctor. I should be an engineer. Um, but in all seriousness, I didn't want to do organic chemistry. I hated chemistry so much. I took a full year of inorganic chemistry, hated it. So I took organic chemistry. Oddly enough, I finished my bachelor's degree. I'm working on my master's degree in water resources. I begrudgingly take a water chemistry class. I think to myself, oh man, this is the only one that fits in my schedule. If I don't take this class, I'm going to have to take a whole nother semester in my master's degree. If I take it now, I can just be done and get my degree and get to work. And so I took the water chemistry class. And I'll tell you what, that water chemistry class was probably one of my 3 favorite classes I took in college. I absolutely loved it. I don't know why. I just adored water chemistry. It was fascinating to me. So I don't know. It's weird. I do enjoy, when I say for all my chemistry nerds, I think I might be one of them. So thanks for pointing that out, Randy. All right.
I think it was a comment, not a question. Anyway.
It was definitely a comment that I am a chemistry nerd, and I will gladly admit that. Well, for those still on the line, thank you so much for being with us today. Please, please, please have a safe and fun Memorial Day weekend. I'm shocked that we had 45 people still show up for this today. I was thinking when we had about 50 or so sign up, I was thinking, well, we'll probably get 20 or 25 because they signed up on Monday or Tuesday, forgetting that it's Memorial Day weekend. So I was assuming that we'd only have a fraction of the people that we had actually show up. But the fact that almost 50 of you showed up was pretty impressive. So thank you so much for attending today. If you want any more information, please reach out. I'd be happy to help you. We're going to be starting in June, going back out and meeting and doing lunch and learns where we can. So if you want me to come and give a presentation in your office and get the not only the Jason Allen version, but the live Jason Allen version, which some of you may actually just prefer the televised Jason Allen version or the YouTube version. That's probably safer for everybody. But if you need anything, please let me know. Have a safe Memorial Day weekend. Look out on Tuesday. I'll be sending out the invite for next week, which will be our final pajama presentation about advanced PowerPoint techniques. I hope to see you all there. Randy, anything for the fine people before they go?
Have a nice Memorial Day.
Wonderful. I think, Heather, I don't know if you're still on. I think she had another thing that she had to run to. Mike, I'm going to unmute you here. Anything before we go?
Have a great weekend, everyone. Thank you, Jason.
Okay. Thank you. All right. And I think, Heather, are you there? I think she left. But anyway, thank you all so much. Happy Memorial Day. Be safe. Stay healthy. And we hope to see you in person soon. Have a great one.